Our planet holds an incredible history, a story etched in stone and bone. It's a tale spanning billions of years from a fiery birth to the emergence of life itself. Today, scientists are piecing together this intricate puzzle, using cutting-edge technology to unravel Earth's remarkable journey. Imagine a time when continents drifted, oceans swirled, and volcanoes erupted with unimaginable force. This was Earth's early history, a time of immense change and upheaval. It's hard to fathom the sheer scale of geological time, but by studying ancient rocks and fossils, scientists are revealing the secrets of our planet's past. These discoveries aren't just for academics tucked away in labs. They're rewriting our understanding of the planet we call home. Each new fossil, each ancient rock formation adds a new page to Earth's epic biography. This ongoing quest to understand our planet's past is driven by a fundamental human curiosity. It's a desire to know where we came from and where we might be going. The Hadean Aeon, aptly named after the underworld of Greek mythology, was a time of intense heat and chaos. This period, which lasted for about 600 million years, was marked by extreme conditions that shaped the very foundation of our planet. It began about 4.6 billion years ago with the formation of our solar system. The birth of the solar system was a monumental event, setting the stage for the creation of planets, moons, and other celestial bodies. Imagine a swirling cloud of gas and dust gradually coalescing under its own gravity. This nebula, a vast and turbulent cloud, was the birthplace of everything we know in our solar system. At the center of this cosmic maelstrom, our sun ignited, bathing the surrounding space in light and heat. The ignition of the sun was a cataclysmic event, providing the energy needed for the formation of planets. Around the young sun, smaller clumps of matter began to accrete, drawn together by gravitational forces. These clumps collided and merged, growing larger and more complex over time. One of these clumps would eventually become our Earth. This process of accretion was violent and chaotic, with countless collisions shaping the young planet. Early Earth was a molten inferno, bombarded by asteroids and comets. These impacts were so frequent and intense that they kept the surface in a constant state of turmoil. The energy from these impacts, combined with the heat generated by radioactive decay within the planet's core, kept the surface in a molten state. This molten state was crucial for the differentiation of Earth's layers. It was a time of unimaginable violence, far too hostile for any form of life to exist. The surface was a seething mass of lava and volcanic activity, with no stable land or water. Yet from this fiery chaos, our planet began to take shape. Over millions of years, the surface gradually cooled, allowing the formation of a solid crust. Heavier elements like iron and nickel sank towards the center, forming Earth's core. This process, known as differentiation, was essential for the development of Earth's magnetic field. Lighter elements like silicon and oxygen rose to the surface, forming the planet's crust. This crust would eventually become the foundation for continents and oceans. This early period of Earth's history is shrouded in mystery, as the intense heat and geological activity have erased much of the evidence. The constant reshaping of the surface has left few clues for scientists to study. But scientists, like detectives at a cosmic crime scene, are piecing together the clues, analysing ancient rocks and meteorites to reconstruct this crucial period of planetary formation. By studying these remnants, they hope to unlock the secrets of Earth's violent beginnings and understand how our planet evolved into the habitable world we know today. As Earth cooled and solidified, a new chapter in its history began. The planet, once a molten ball of chaos, started to take on a more stable form. This transformation set the stage for the incredible journey of life that was about to unfold. The oceans formed as water vapor, released from volcanic eruptions, condensed and fell as rain. These early oceans were the cradle of life, providing a nurturing environment where the first simple organisms could emerge and evolve. This primordial soup, rich in dissolved minerals, set the stage for one of the most significant events in Earth's history, the Great Oxidation Event. The minerals in the water provided essential nutrients that fueled the growth of early life forms, creating a thriving ecosystem in the ancient seas. About 2.4 billion years ago, a new type of life emerged, cyanobacteria. These tiny yet powerful organisms were among the first to harness the energy of the sun, a revolutionary development that would change the course of life on Earth. These microscopic organisms possessed a remarkable ability. They could photosynthesize. This process allowed them to convert sunlight into energy, using water and carbon dioxide. And in doing so, they produced oxygen as a byproduct. Just like plants today, they use sunlight, water and carbon dioxide to create energy, releasing oxygen as a byproduct. This oxygen was initially absorbed by the oceans and reacted with dissolved iron, creating vast deposits of iron ore. At first, the oxygen released by these early life forms reacted with iron in the oceans, forming vast deposits of iron ore. This process continued for millions of years, gradually depleting the iron in the oceans and allowing oxygen to start accumulating in the atmosphere. But eventually the oxygen began to accumulate in the atmosphere, forever changing the chemistry of our planet. This accumulation of oxygen in the atmosphere was a slow but steady process, taking place over hundreds of millions of years. This rise of oxygen had a profound impact on the evolution of life. It created an environment where more complex organisms could develop, leading to an explosion of biodiversity and the emergence of new life forms. It paved the way for the development of more complex, oxygen-breathing organisms. These organisms were able to harness the energy stored in oxygen, allowing them to grow larger and more complex than their anaerobic predecessors. The Great Oxidation Event was a pivotal turning point in Earth's history, marking the transition from an anaerobic to an aerobic world, a world where life as we know it could thrive. This event set the stage for the evolution of complex life forms including plants, animals, and eventually humans. The oxygen-rich atmosphere we enjoy today is a direct result of this ancient transformation, a testament to the power of tiny organisms to shape the destiny of an entire planet. Section 4. The Cambrian Explosion, Life Finds Its Feet. This period marks one of the most significant chapters in the history of life on Earth, a time when the planet's biosphere underwent a dramatic transformation. After the Great Oxidation Event, life on Earth was still relatively simple, consisting mostly of single-celled organisms. These microscopic entities had dominated the planet for billions of years, thriving in a world that was vastly different from the one we know today. Then, about 540 million years ago, something extraordinary happened, the Cambrian Explosion. This event was not a literal explosion, but rather a metaphorical one, signifying a rapid diversification of life forms in the fossil record. Over a relatively short period, geologically speaking, there was an unprecedented burst of evolutionary innovation. This era saw the emergence of complex organisms with specialized structures and functions, a stark contrast to the simplicity of earlier life forms. In the warm, shallow seas of the Cambrian period, life diversified at an astonishing rate. These marine environments provided the perfect conditions for a variety of organisms to flourish, leading to an explosion of biodiversity. New body plans evolved, leading to a dazzling array of creatures. These new forms included the first appearances of many major groups of animals that still exist today, such as arthropods, mollusks, and echinoderms. Some were bizarre, like the five-eyed opabinia, with its unique appendages and unusual body structure, while others, like the trilobites, would become iconic fossils, their segmented bodies preserved in exquisite detail. These creatures provide a window into the incredible diversity of life during this period. This sudden surge in diversity is a source of ongoing research and debate among scientists. Researchers are continually uncovering new fossils and using advanced technologies to understand the complexities of this pivotal time in Earth's history. Some theories suggest that changes in ocean chemistry, perhaps an increase in oxygen levels, may have triggered this evolutionary explosion. The rise in oxygen could have provided the necessary energy for more complex life forms to develop and thrive. Others point to the development of new ecological niches, allowing for greater competition and specialization among species. These new environments may have driven the evolution of diverse adaptations, leading to the wide variety of life forms that emerged during this time. The Cambrian explosion is a testament to the power of evolution. It demonstrates how life can rapidly diversify and adapt to new conditions, resulting in a rich tapestry of organisms that continue to evolve to this day. It reminds us that life is incredibly resilient and adaptable, capable of evolving and diversifying in remarkable ways, given the right conditions. The story of the Cambrian explosion is a powerful reminder of the dynamic and ever-changing nature of life on Earth, a process that continues to shape the world around us. Section 5. The age of dinosaurs, giants rule the Earth. Following the Cambrian explosion, life continued to evolve and diversify. Dinosaurs emerged in the Triassic period about 230 million years ago and went on to dominate the planet for over 180 million years. An incredible reign. From the mighty Tyrannosaurus rex to the long-necked Brachiosaurus, dinosaurs came in a staggering variety of shapes and sizes. They roamed the Earth from pole to pole, adapting to a wide range of environments. Some were ferocious predators, while others were gentle giants, content to graze on vegetation. The age of dinosaurs wasn't without its challenges. Volcanic eruptions and asteroid impacts periodically reshaped the planet, leading to mass extinctions that wiped out many species. Yet these events also created opportunities for new forms of life to evolve and flourish. The reign of the dinosaurs may seem like a distant chapter in Earth's history, but their fossils continue to captivate our imaginations. They remind us of the power of nature, the grandeur of evolution, and the impermanence of even the most dominant